Hi, my name is Chris Woodward, and thanks for joining me for this OrangoDB Lunch and Learn session. Today we'll be taking a look at knowledge graphs. We'll take a look at what a graph database is, what knowledge graphs are, and how knowledge graphs are used and built. A graph database stores schema-free objects referred to as vertices or nodes, which can contain properties and can also describe relations between those objects. These are often referred to as edges. Here's an example of a graph database using the IMDb dataset. Here we're seeing the connections between movies, their directors, and the actors, as well as the connection that all of these movies have to the comedy genre. You can start getting more relationship information as you further describe the node. So for example, the movies contain description information, release date information, as well as a number of other attributes. As the same thing along with the actors and directors, they also have relevant information associated there. So depending on what the query is you're looking for, you might be interested to find out which movies a specific director has directed. And this is one way to do that. Some other use cases for this would be taking that IMDb example a step further and saying, which movies has a director directed, but then how many times does it seem like that director is using the same cast for their movies? Or social networks, trying to recommend new friends to people that maybe have friends in common. Knowledge base is this sort of connecting of knowledge to try and potentially infer new information out of it, which we'll see when we start looking at the knowledge graph side of things a bit more, as well as machine learning and fraud detection use cases. If you are interested in seeing a kind of a live use case or a real world use case, check out the graph course for freshers. This one covers the connection of flights and airports, as well as kind of can take you from zero knowledge about graphs, graph traversals, to advanced AQL graph queries. So what is a knowledge graph? Well, this is a definition from Wikipedia that says a network of entities, their semantic types, properties, and relationships. So really similar sounding to graphs, but the network of entities I like because it specifically calls out that this is just an entity. So an entity could be a graph itself. So you could have a network of graphs, a graph of graphs, and that is kind of what makes up knowledge graphs, or what makes knowledge graphs so powerful. There are semantic types. This has to do, if you're familiar with this sort of class hierarchy and class structure, creating definitions, taxonomies and ontologies used in the semantic web world especially. So defining what is a person, what attributes does a person have, and being able to potentially get very granular in defining what the data is and how they're related. And this comes along in the form of properties and relationships as well. This is going to be a very, one of many definitions for knowledge graphs as well. So definitely check out that link for a little bit more on defining a knowledge graph. But for our purposes, typically we look at that as just sort of this combination of graphs containing graphs, but there's a lot more to it from there. So why are we interested in this graph of graphs, or this knowledge graphs? Well, one is we want to make data more accessible. The way that we can do that is by defining standards that state how the data is structured, or how these relationships are formed. And then we can start trying to infer new data from that once we can start incorporating knowledge sources from all over. So for example, with Wikidata, containing a high amount of data from multiple repositories, including multilingual sources. And as we'll see with some of the use cases, such as like enterprise knowledge graphs, bringing in some of that. Here's an example of a knowledge graph that you probably see every day or on a frequent basis. This is doing just a quick search for Sir Arthur Conan Doyle on Google. The thing to kind of call out here is that there's a lot of information here that's gathered from a lot of different sources. This info card is the most well-known, I would say, form of knowledge graph use, and just really search engines in general are great use cases for knowledge graphs. So this is pulling actually from Wikipedia. And this is pulling the information that's already been supplied there. As you can see, it calls out Wikipedia here, but then also we can see the connected movies. This may be coming from Wikipedia or from other sources, especially with the addition of the cover art. The quotes have also started being pulled in, but then we can also see that people ask for section. This is something that Google can bring in as well. So while it's providing the information that you would normally expect for the search, a lot of the links, to other external sources, now we get this additional thing on top where we can quickly learn, was Arthur Conan Doyle Jack the Ripper? And I'll leave that one for you to find out. But this is just a nice example of a way to visualize what knowledge graphs can accomplish. I would say that determining if Arthur Conan Doyle was Jack the Ripper is definitely a way of inferring new knowledge. So some other use cases are natural language processing, enterprise knowledge graphs, customer 360, and compliance. We'll take look at a couple in this video. Is probably all we'll have a time for. But so, for example, here's a use case for NLP, natural language processing, and this is Sir Arthur Conan Doyle was a British writer most known for the Sherlock Holmes novels and short stories. So this is actually an example that we could use for entity detection. So we're trying to pull out entities from this text and try to start linking it to useful information. So as we saw, Sir Arthur Conan Doyle, we start there, that's a person, and we can say it's a British writer. So now we can start linking this the sentence potentially to other British writers. That's known for Sherlock Holmes novels and short stories. So we could actually start building a graph out of just this sentence alone for Sir Arthur Conan Doyle. And then we could start linking these entities to other data about them that might define them better. Here's an example of what that graph could start looking like in more of a diagram form. But as you can see, the connectedness there, and then I also wanted to call out the connectedness to the person. So this is where we're talking about defining objects or defining classes for your knowledge graph. And this is something that if you start doing this on a global scale, that we all can sort of agree on what a person is, then you can really start getting powerful searches for British writers and what that means to be a British writer, and get a list of British writers that maybe this sort of list never existed before. Moving on, we'll take a look at an enterprise knowledge graph, and I just want to provide a really quick example of something that might fall under the guidelines of an enterprise knowledge graph, which is bringing in knowledge from across an organization in areas that normally might be kind of siloed away or just really have no reason to have a connection. Now, if you do bring all those in, you might be able to gain a new insight. So this is an example for organizing a meetup for hopefully in the future, whenever we can all start meeting up again in person. This would have the criteria of fitting a team budget, not conflicting with any schedules, so making sure no one has vacations planned or holidays or something, places that we haven't gone before. And for a lot of us at ArongoDB, we'd like to do some outdoor activities, so something like hiking or something. So we'd want to make sure wherever we were going allows for that. This could immediately start benefiting from different data sources inside of a large enterprise, where even doing something like this can start to get a little complicated. So you might need access to the engineering calendar or something like some sort of management system where employees go to request time off. We need to be able to make sure that we're not planning this meetup at a time that somebody's going to be on vacation, as well as potentially connecting to a financial data source that's going to provide us with information about the team's budget and what they would have available at that time, whenever it is that we would actually be able to schedule this. Information on previous meetups or where employees live, so that we're not planning this meetup at a place where an employee lives already, or somewhere that we've already been. We want to go somewhere new and exciting. And then we can even start pulling in external information, connecting to external repositories for weather, climate, region information to give us information about, does this area have a rainy season? Is this going to be good during these months that we can go, or what's the outdoor activity like there? Taking it kind of more to the business side of things, this is the example of what an enterprise might use it for, to do things like figure out fraud detection, or this Customer 360, where you can take in a lot of information such as CRM information, transactions, events, logging information, and then, as mentioned before, even bringing in this external information and storing it as a graph. In ArongoDB, that has the added advantage of being a multi-model enterprise knowledge graph, where now you can structure it in whatever way makes the most sense and improve your insights that you would get with things such as like the recommendation system that we were talking about before, or getting a better view, more holistic view of your customer information. And the final thing I want to talk about is the semantic web, and just this idea of linked data, vocabularies, and how, an approach for trying to structure this in a way that does allow us to query it and infer new information. A great place to start, I should say, is the Resource Description Framework, or just RDF. The core structure of the abstract syntax is a set of triples, each consisting of a subject, predicate, and an object. And that comes from the RDF concepts from W3. And RDF is going to be I would say one of the most popular places to start. There's a bunch of different serialization formats you can use, such as Turtle and other formats for saving out RDF documents, but they all are deriving from this. And then you can start looking at things like OWL for ontology definitions and understanding more of that class syntax. One last thing that I wanted to mention was RDF star. And RDF star extends this idea of RDF with a convenient way to make statements about other statements. And why this is important is how this ties into property graphs such as ArongoDB. So now we can have this rich description of relations and properties on the edges and nodes, and store them as listed here, as a sort of nested statement within a statement. And that really starts taking the power and convenience of and readability of a property graph and allowing it to easily translate into RDF. And so that is where I will leave it. Hopefully you have a lot of questions, and if you do, please reach out to us. This hopefully has served to pique your interest in a lot of these technologies that exist. There could definitely be 20 more ArongoDB Lunch and Learn sessions for each one. And if you are interested in one, please let us know. Reach out to us on our community Slack, our GitHub, Google Groups, learn@arongodb.com. Whichever you prefer. You can also contact me directly, chris.arongodb, on the Slack channel as well. Thank you again for watching, and have a great day.